In the crucible of production, where systems are tempered by the relentless heat of constant use, a problem emerged with Claude Code, a linchpin in our operation. The issue persisted despite attempts to reforge it anew, but we found a solution that held fast and ran unyielding for 43 days without fail. This tutorial will guide you through the diagnostic approach, a method crafted to identify and rectify issues within Claude Code when simple reinstallation falls short. In this forge, you will learn how to test your code on a pristine machine, compare environments between systems, and make crucial adjustments to restore functionality without resorting to unnecessary cleanup or demo machines. Join us as we forge resilience into our production system, one step at a time. Chapter: The Problem in the Crucible of Production, where the molten code of Claude Code must flow without fail, a malfunction can forge a crisis. A broken workflow, once patched with a simple reinstall, has proven resilient, refusing to yield. The cost of this manual endeavor, in a system of real consequences, amounts to an hourly toll of $50. The common solution, like a brittle anvil, cracks under the weight of this task. It suggests starting afresh on a separate machine, with identical configurations and versions. Yet it fails to account for the myriad ways in which environments can differ, even within seemingly identical setups. Our artisans, faced with this broken method, have already attempted to replicate their environment on another machine, only to find that Claude Code functions as expected there. The reason for this disparity lies in the subtle variations between environments, variations that the hasty solution overlooks. The failure mode of this approach is twofold. First, it neglects to identify the precise environmental differences that cause the issue. Second, it assumes that a clean machine will always exhibit the same problems as the original environment, which is not always the case. The reason for this disparity lies in the subtle variations between environments, variations that the hasty solution overlooks. In the forge of production, where every minute's delay can mean substantial losses, a diagnostic approach that lacks precision and thoroughness is akin to wielding a blunt hammer, inefficient and prone to shattering the very code it seeks to mend. This tutorial will guide you through a more robust diagnostic approach, one that forges a path towards identifying and resolving environmental issues within Claude Code, ensuring your production system remains unbroken and unyielding. Chapter: The materials in this diagnostic approach tutorial will forge a robust solution to address erratic behavior in Claude Code within a production system. Our materials, carefully chosen for their reliability, efficiency, and compatibility, will be meticulously shaped and tempered to ensure a smooth operation. 1. Python 3, 9, 7 free obtained from Python. Org selected due to its wide support, extensive library ecosystem, and stability in production environments. Python 3, 9, 7 offers performance improvements and new features over previous versions while maintaining backward compatibility. 2. Anaconda 2021, 11 free obtained from Anaconda. Anaconda is a distribution of Python that includes packages for data science, machine learning, and scientific computing. It simplifies package management, reducing conflicts and ensuring consistency across projects. 3. Poetry 1, 12 free obtained from Poetry. Use-case. Poetry is a tool for dependency management and packaging in Python projects. It streamlines the installation, upgrading, and building of packages while ensuring reproducibility across environments. 4. Virtualenv 20, 2, 3 free obtained from pip or directly via Virtualenv. Pipa. Virtualenv creates isolated Python environments that allow for separate configurations and package installations, helping to prevent conflicts between project dependencies. It streamlines the installation, upgrading, and building of packages while ensuring reproducibility across environments. 4. 5. Git 2, 37, 0 free obtained from GitSCM. Git is a distributed version control system used for managing source code changes. It enables collaboration, branching, merging, and tracking of changes across multiple developers and platforms. 6. VS Code 1, 73, 2 free obtained from Visual Studio. VS Code is a lightweight open-source code editor that provides rich features for Python development, including syntax highlighting, intelligent code completion, debugging tools, and integration with Git. It enables collaboration, branching, merging, and tracking of changes across multiple developers and platforms. 6. In this diagnostic approach, we considered alternatives such as PyCharm and Conda environments. However, Anaconda's broad support for data science packages, combined with Poetry's package management features, provided a more comprehensive solution for our production needs. While PyCharm offers powerful IDE functionality, its cost made it less suitable for this particular application. Virtualenv was chosen over other isolation tools due to its wide adoption and compatibility with the selected materials. Finally, Git and VS Code were selected for their versatility in managing and editing code across different platforms. Chapter the build. In this section, we shall forge a diagnostic approach to mend the malfunctioning Claude Code in a real production system. A fresh slate devoid of the bug serves as our anvil, while the M1 Air functions as our furnace, bearing the same account and version as the ailing system. First, we must install Claude Code on the clean machine using the following command: sh-pip install Claude Code expected output. No output indicates successful installation. Verify by importing the package in Python. sh python c import Claude Code. If Claude Code functions correctly on the M1 Air, our investigation shifts towards environmental differences between the two machines. We begin by comparing the path variables: sh echo $pathtr \npath M1 Air, txt echo $pathtr \npath production. txt. The above commands generate two text files, one for each machine, listing their respective path variables. Comparing these files will reveal any discrepancies that may be causing the issue. Error encounter 1. If the comparison reveals a missing directory or conflicting version in the path of the production system, we must address this by updating the path variable accordingly. Open ~/bashrc and add / modify the appropriate line. sh export path equals your corrected path. $path save the file and run the following command to ensure the changes take effect immediately. sh source ~/ bashrc error encounter 2 should Claude Code still malfunction, we turn our attention towards local configuration files. Error encounter 1. If the comparison reveals a missing directory or conflicting version in the path of the production system, we must address this by updating the path variable accordingly. We wipe the user-specific cache and settings by deleting ~/ Claude / and ~ Claude JSON. Execute these commands: shrem ref ~/ Claude /rem ~ Claude JSON. Restart your terminal or run the following command to reload the modified files: sh source ~/ bashrc now. Test Claude Code again to verify if the fixes have rectified the issue. sh python c import Claude Code. Should the diagnostic approach fail to resolve the problem, further investigation and experimentation may be required. Forging a deeper understanding of the malfunction. We wipe the user-specific cache and settings by deleting ~/ Claude / and ~ Claude JSON, but with each step taken, we bring us closer to a fully functioning Claude Code in our production system. The journey of crafting solutions is never-ending, and so too must our vigilance and determination remain. Chapter Deep Dive. In the crucible of production, where systems are forged under relentless pressure, a malfunction in Claude Code threatened to halt our progress. Reinstallation, the humble remedy for many such issues, proved futile. This predicament required a deeper dive into the diagnostic approach, an exploration of the underlying machinery and the artful balance that keeps it functional. At its core, Claude Code's behavior is governed by its architecture, a delicate symphony of components interacting in harmony. Understanding this structure is crucial to identifying why it behaves as it does. The design emphasizes modularity, allowing for seamless integration with various systems. Yet, this very characteristic can make troubleshooting complex, for if one module falters, the entire construct may quiver. Two primary pitfalls often plague our craftsmen. First, misconfiguration of modules leading to incompatibilities. Second, environment-specific variables left unaccounted for. The former is a product of haste and insufficient testing, while the latter stems from assumptions about consistency across systems. Both errors can lead to the erratic behavior we witnessed with Claude Code. To address these issues, our diagnostic approach involves two primary steps: validation and comparison. First, we test Claude Code on a pristine machine, a M1 Air in this instance, with an identical account and version. If it functions correctly there, the problem lies within the environment, not within Claude Code itself. Next, we meticulously compare the environments between the faulty system and our clean machine, seeking out discrepancies that could explain the anomalous behavior. A crucial point of focus is the path variable, a critical environmental factor that dictates where Claude Code searches for executable files. Once identified, we wipe /Claude/ and /, Claude, JSON, two key directories containing user-specific configurations, as our initial attempt at rectifying the environment's imbalance. This process, while rudimentary, often resolves many environmental issues by resetting Claude Code's configuration to its default state. In this forge, we value functionality over aesthetics. Our diagnostic approach is a testament to that ethos, a methodical, weighted exploration of each component and the environment in which it operates. By understanding why things work the way they do, we can better anticipate and rectify malfunctions before they disrupt our production system. This real-world fix, forged under pressure and proven effective, serves as a reminder of the precision and skill required to maintain harmony within our digital crucible. Chapter Stress Test in the Crucible of Real-World Application, the forging continues. Today, we focus on stress testing Claude Code in a production system, revealing any fissures that may have formed under duress. The first signs of strain emerged when Claude Code began to behave erratically, refusing to yield desired results despite repeated attempts at reinstallation. This was no mere glitch. It demanded our full attention as a real production system hung in the balance. Under the watchful eye of our forge, we conducted exhaustive tests on a pristine MacBook Air M1 chip, equipped with the same account and version as the troubled system. As Claude Code performed flawlessly on the test machine, we isolated the issue within the original environment, not a bug in Claude Code itself, but rather an environmental factor. With a clear direction, we commenced our investigation by meticulously comparing the path variables between machines. This comparison revealed subtle differences that could have potentially caused the observed behavior. With these discrepancies identified, our focus sharpened to address the environment irregularities. Our first attempt at rectifying this environmental anomaly involved wiping essential Claude Code directories, /Claude/ and /, Claude, JSON. This initial adjustment aimed to restore a clean slate for Claude Code within the compromised system, ensuring it would once again function as intended under the rigors of real-world usage. In this instance, stress testing not only validated but also vindicated our forging process, for without it, we may have overlooked the environmental factors that ultimately hindered Claude Code's performance. Thus, a system that hasn't been stress-tested remains an unfinished masterpiece, one that has yet to prove its mettle under pressure. Chapter The Output. In this diagnostic approach, we forged a solution to mend a malfunctioning Claude Code within a production system, without the need for a costly reinstallation. The outcome is twofold: a restored functional Claude Code and a better understanding of its environmental dependencies. First, we constructed a clean environment by deploying Claude Code onto an M1 Air with the identical account and version as the afflicted system. Our forge yielded a success story. Claude Code operated smoothly on this machine, confirming that the root cause lay in the environment rather than a code bug. Next, we compared the path settings of both machines to pinpoint the differences that may have contributed to the malfunction. This comparison served as the blueprint for correcting the environment and restoring Claude Code's proper functioning. As the first attempt at environmental repair, we eradicated any residual configuration data by purging /Claude/ and /, Claude, JSON. With these files eliminated from the afflicted system, Claude Code returned to its original state and began operating as intended. In conclusion, this diagnostic approach allowed us to identify, isolate, and rectify the issue plaguing Claude Code without resorting to a costly reinstallation. The time saved through this targeted solution will not only contribute to increased productivity, but also ensure that our systems remain robust and resilient in the face of future challenges. As the forge cools your apprentice, you've molded a diagnostic approach worthy of our arsenal. Test Claude Code on a clean machine should it falter again. If it functions there, the environment, not the code, is the culprit. Examine path disparities between machines to pinpoint the source of contention. A fresh start with /Claude/ and /, Claude, JSON erased may prove a viable remedy. Now, let the anvil rest. Your next project awaits.